All right, this is some statistics here. So we're going to do mean, median, mode, and range. Then we're going to do dot plots and histograms, followed by box and whisker plots in this video. Okay, so we have the notes all filled in on Schoology, so you can get all the definitions there. But I'm just going to talk about them as we go along. So the first one we're looking for is the mean. The mean is the average, the arithmetic average of the data set. So what we're going to do to find the mean is we're going to add up all of the data, and we're going to divide by however many that there are. So let's add those all up. Let's use our calculator. Okay, and I'm going to add up all those data points. So let's see, put it over here. We got 89 plus 90 plus 88 plus 91 plus 92 plus, so that's an 82, plus 90 plus 88 plus 88 plus 86 plus 90 plus 92 plus 87 plus 89 plus 86. I get a total of 1,236. 1,236. Okay, and then it's 2 weeks, so that should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 values, so I'm going to do 1236 divided by 14. Hit enter. We get a decimal or a fraction. Let's hit not escape. Let's hit control enter. Turn it into a decimal. That's 88.3. Okay, we could say 88.3. Okay, to find the median, that's the middle value. I need to order these from smallest to largest or largest to smallest. Let's do smallest to largest. The smallest number I see here is 82. 86. 86. 87. I have 3 88s. 89. 2 89s. 3 90s. A 91, and then a 92. Okay, so let me make sure that's 14, 3, 6, 9, 12, 14. Yep. Okay, so the middle number, so I can cancel off from the beginning and end until I get to the middle. Okay, so here's my middle. So there's not a middle value, so I have to take the average of the two middle values. So I'm going to do 88 plus 89 and divide by 2, which is going to give me 88.5. So my median is going to be halfway between 88 and 89, which is 88.5. Okay, the mode is the number that appears the most. So I believe 88 appeared 3 times and 90 also appeared 3 times. So my modes are going to be 88 and 90 because they both appeared 3 times. The high temperature, the daily high was 88 3 times, and it was 90 3 times. All right, the range is the largest minus the smallest. So my range is going to be 92 minus 82, which is 10. Okay. All right. The number of points scored by a football team during their 16-game season. So to find the mean, I'm going to add up the scores they had from each game and divide by the number of games, which is 16. So we need to add up all of those data points. If we will do this half first. So I have 7 plus 31 plus 33 plus 16 plus 30 plus 45 plus 25 plus 25 plus 25 plus 16 plus 28 plus 24 plus 20 plus 33 plus 31 plus 10. That's odd that they would score 25 points in a game, and then they did it 3 times in a row, which is interesting. It's kind of hard to get 25 in a football game. Okay, I'm going to hit enter. I got 399. So if I add up all the scores from all 16 of their games, I get 399. And then I divide by 16 because there were 16 games. Control enter, we want a decimal. Okay, it divided by 16 twice for some reason. We get 24.9. So the mean is 24.9. Okay, I'm going to order this. I'm going to put these in order. So we got 7. Let's see, 16, 16. Oh, we had a 10 in there. 10, and then 16, 16. 20, 24. And then we have 25 3 times. 28, 30, 31 twice, 33 twice. And then they exploded for 45 points in this game. Okay, just to make sure, 16, 2, 4, 6, 8, 10, 12, 14, 16. Okay, so if I want to find the middle, start canceling off from one end to the other. Okay, so we have 25 and 25, so our median is going to be 25. The mode is the one that occurred the most. So in this case, the one that occurred the most is 25. It happened 3 times. 1, 2, 3. 31 happened twice. 33 happened twice as well. 16 happened twice. But 25 happened 3 times. And then finally, the range is the largest minus the smallest. So 45 minus 7 gives us a range of 38. Okay. Let's look at this example right here. Okay, Jordan and Ben exercise at the same gym. The table below shows the number of calories they burned in each of their last 5 workouts. How many calories would Ben need to burn in his next workout to have the same average as Jordan? So we know the mean for Jordan is equal to the mean. We want it to be equal to the mean for Ben. Okay, so let's find the mean for Jordan first. Okay, so we're going to find the mean for Jordan first. So to do that, we're going to add up all of Jordan's calories he burned each workout, and we're going to divide by 5 because there's 5 workouts. So 850 plus 674 plus 729 plus 658 plus 614. 3, and then we're going to divide by 5 to get 705. 35, 25, and then we get 705. Okay, which means that we want the mean for Ben to equal 705. So for Ben, we're going to do 705 equals, okay, so Ben's doing a 6th workout. So we're going to end up dividing his total by 6. We're going to add all of these together. Okay, we won't be able to add them all together because we don't know what the last one is, the 6th one. We're just going to call that X. So we're going to add all of these together and then have plus X. So if I use my calculator here, I'm going to have 716 plus 635 plus 802 plus 687 plus 630 and then plus X, right? But the calculator is not going to be able to do that. So we're going to leave off the plus X and then put it back. So 3470 plus X. 3470 plus X. Okay, and then we're going to need to solve for X. We're going to need to solve for that last workout, how many calories he burned in that last workout. So to do that, we're going to multiply both sides by 6. Okay, that's going to be 4230, I believe. So 6 times 705, 4230. We're going to subtract 3470 from both sides, and we get 760. So we subtract 3470, and we get 760 equals X. So how many calories would Ben need to burn in his next workout to have the same average as Jordan? He would need to burn 760 calories. Okay. And so that's mean, median, and mode. And then we have an example of using the mean to solve for one of the averages or one of the data points. Clear. Okay, next up is dot plots. So dot plots, you just are plotting each individual data value from the set of data. Okay, so for example, we have a 25, we have a 45, we have a 26, we have a 35, we have a 31, we have a 26 again. So I'm going to stack it on top by putting a dot right above the dot that's already at the 26. I have a 30, I have a 28, a 29, the 26, so I'm going to stack it. The 28, I'm going to stack it. 26, stack it. 27, 27, 28, and 28. Okay, so Manuel plans to buy a new car with 26 miles per gallon gas mileage. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. So what I noticed about this data is I noticed that there is a cluster here. Okay, this is a cluster because that's where most of the data is. And then I also noticed an outlier, right, which is way outside where all the other data points are. This car over here has 45 miles per gallon. But most cars have about 26, 27, 28, 29 miles per gallon. Most cars are right here in this cluster. Okay, so how does the fuel efficiency of the car he wants to buy? He wants to buy one with 26 miles per gallon. So how does the car with 26 miles per gallon compare to the fuel efficiency of the other cars? It's very similar, right? We could say it's the fuel efficiency of the car he wants is similar to the fuel efficiency of the cars on this in the city. Okay, something along those lines. Okay. And that's dot plots. That's essentially what a dot plot is. It shows the individual data points. Okay. Next up are so then you have a couple examples. Okay, and then histograms, instead of showing individual data points, they show intervals. So they show the shape of the data by looking at the data in intervals. So the first interval is 51 to 60. So 51 to 60. That's going to be 1, 2, 3, 3. So you're going to put a bar 3. Okay, 61 to 70. 1, 2, 3, 4, 5, 6, it looks like. So 6. 71 to 80. 1, 2, 3, 4, 5, 6, 7. Seven, it looks like. Okay, 81 to 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we missed one of the 70 ones. So this one really should have been 8 up here. Okay, and then last one, 91 to 100. 1, 2, 3, 4, 5, 6. So there is our histogram. Okay, let's answer the question. So the histogram table contains scores on an algebra test. Create a histogram to represent the scores. So we have the scores. How many total students took the test? Let's add up each category here. So this one's 3, 6, 8, 12, and 6. So that's 26. It should be 35 total, right? If you add those all up. Okay, or you have 5 by 7. 5 times 7 is 35. Okay, how many students scored at least 71? So that means everything to the right of this one, right? So we have 8 plus 12 plus 6. That's going to be 26 students, right? Okay, can you determine the highest grade from the histogram? Right, that answer is going to be no. Histograms do not give individual data points, right? We know that 6 people got between a 91 and 100 based on the histogram, but we don't know what those actual scores are. We would from the table here, but if we didn't have the table and we just had the histogram, we can't tell what score they got specifically. We can just know that between 91 and 100, or 6 of them got between 91 and 100. We don't know if they all got 91s or all got 92s, or if anyone got 100. Histograms don't give individual data points. All right, and then the last one on here is going to be a box and whisker plot. Okay, the box and whisker plot, it basically splits the data into quartiles, quarters, if you will. So you'll find this is 1/4 of the data is in this part, 1/4 is in this part, 1/4 here, and then 1/4 here as well. Okay, so let's do an example. Okay, and then they got a whole bunch of questions here for us to solve. Okay, let me zoom out actually so we can get all the questions in one. There we go. Good. Okay, the resting heart rates in bears in beats per minute. I'm sorry, the resting heart rate in beats per minute. I don't know why I got bears instead of beats. Okay, the resting heart rate in beats per minute of a group of people are given below. Find the 5-number summary. So minimum, lower quartile, median, upper quartile, maximum. This is the 5-number summary. Okay, and then draw the box and whisker plot and answer the questions. Okay, so the first thing I'm going to do is I'm going to order these values in largest or smallest to largest. So I think the smallest on here is 55. Okay. Nope, it's 50. 50 and then 55. Okay, and then we have 58. And then we have 62 and then 64. But we also had a 60 in there, so it should be 60, 62, let's do 60, 62, 64. Good, good. And then we have 68, 70, 72. 68, 70, 72, 76, 84, 92. 76, 84, 92. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what we're going to do now is we got to find the median first. Well, we can fill our minimum and maximum. Our minimum is 50, and our maximum is 92. Okay, so our median is our middle number. So if I were to count 1, 2, 3, 4, 5, 6, and then from the other side, 1, 2, 3, 4, 5, 6, right? Or I could, try and cancel them off. Okay, my median would be halfway between 64 and 68, which is going to be 66. Okay. Okay, and then now we have to find, so here's my median right here. Okay, so I have 6 numbers to the left and 6 numbers to the right. So now I need to find the median on the left and the right. So on this one, I have 1, 2, okay, and then so between 58 and 60 is 59. So my lower quartile is 59. My upper quartile is going to be between 72 and 76. That's going to be 74. So I'm finding the median, and then I'm finding the median of the left side. Here's the median of the left side, 59, and the median of the right side, 74. So I basically found the median of the whole thing, the median of the left side, the median of the right side. And what that's done is it split the data into 25%, 25%, 25%, 25%. So it has split it into quartiles, 25% pieces, right? Each of these sections has 1/4 of the data, which in this case, 12 data points, there's 3 in each section, okay? All right, so now we have to graph it. So what I'm going to do is make it a little wider. Okay, we need to scale our graph. So I'm going to go by 5s probably, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's going to be good. So I'm going to start at 45 and then go 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and then 105. Okay, and then I'm going to plot this. So I'm going to plot the 3 points here, the minimum, which is 50, the lower quartile, which is 59, the median, which is 66, the upper quartile, which is 74, and then the maximum, which is 92. Okay, I'm going to put a box, okay, like this. Okay, and then that's the box, and then this is the whiskers. So we have a box and whiskers, and each one of these represents a quartile, 1/4 of the graph. So again, this is 25%, this is 25%, this is 25%, and this is 25%. Okay, so let's answer the questions now. What is the range? The range is the largest minus the smallest. So 92 minus 50, which is 42. Okay, the interquartile range. Okay, so that's the range between the upper quartile and the lower quartile. So that's going to be 74 minus 59, which equals 15. Okay, that's the range from here to here, 74 to 59. 74 to 59. Okay, what percent have a resting heart rate less than 66? Okay, Well, this again is 66 right here. So that's 50%, right? This would be 1/4, 1/4, 1/4, or let me put it down here maybe. This part right here, let's use a different color. This is 1/4, 1/4, 1/4, and 1/4. So less than 66, that's half, 2/4, 50%. Okay, what percent have a resting heart rate of no more than 74? Okay, so not more than 74 means less than. It's a weird way to do less than 7. So here's 74. So you have 1/4, 1/4, that's 3/4, which is 75%. Okay, what percent have a resting heart rate between 50 and 59? That's this section right here. That's 1/4, 25%. Okay, and then what percent have a resting heart rate between 66 and 92? That's this, and 92. That's 1/4 and 1/4. That's going to be 50%. Okay, and that's mean, median, mode, range, dot plots, histograms, box, and whisker. Okay, we'll do a separate video for the standard deviation and the mean average deviation.